Welcome to episode 45 of In the Terminal. Today we're going to be talking about managing Podman containers as pods. So our first step is, of course, we need the Podman utilities and all the dependencies installed. So we'll do that using DNF and the TAC-Y option, just so it doesn't ask us to confirm. So in a previous episode, which we'll have linked in the show notes, we talked about Podman containers. In fact, that was our first live in-person episode of Into the Terminal. And so we're going to bypass creating just a regular container today. Check that episode out. Instead, what we're going to do is we're going to go ahead and create a pod. This just basically creates a logical container on our system that we can then put containers inside of, and we'll describe pods a little bit more in the second half of the episode. But let's go ahead for now, create a pod. We'll call it ITT for Into the Terminal, because we're really creative in our naming schemes here. And then we're going to do an LS on Podman pod. So the nice thing about Podman is it's fairly well self-contained set of utilities and tools. So like, you can do Podman pod, Podman run, all that within the Podman command. So you can do a listing on the running pods. So one thing I wanted to point out here is we've only created the logical container. Sorry, container is a terrible term to use in this situation. So we've already created the logical box, if you will.
Okay.
There you go. And notice that we already have a container inside of it. So if I do a Podman ps-a, you notice that we have signature ID and TAC infra. That's short for infrastructure, and this is basically the glue, the command and control, if you will, of all these pods. It helps keep the pod established, and that way it's there and ready to go. Pull that in. Not sure what happened. My video cut out for just a second, but it seems like I'm back. So the next thing we want to do is to actually add a container to this pod. So don't let this command feel too daunting. We'll run through it. So Podman, we're instantiating the Podman utility. Run means we want this container to actually start once it's ready, /DT, which means it's going to be running as a process in the background. We're going to add it to the ITT pod. That's what the TAC pod means. And then we're going to give it a location. And that's going to be the RHEL 9 UBI container. So we're going to go ahead and it's going to go out to registry.access.redhat.com and pull down that container. So containers are built in layers, and so it's pulling down several of the different layers. And then once that's done, we'll be able to run Podman PS and see that our new container is actually running. And there it is. Gallant Spence is now running as part of our ITT pod. Scott, before we jump to the second half of the show, anything you want to add?
Only that Podman is called Podman for a reason. It works with pods, right? And a pod is a group of containers. I love how Eric liked to talk about a container of containers. But please stay with us after the transition, as we will go a little bit deeper into what a pod is, as well as give an example of running real applications as a pod. And we'll talk a little bit about orchestration versus automation and how you can go from pods to Kubernetes.
And of course, in the second half of the show, we'll also take your questions live on the air. So we'll see you after the transition. So hello and welcome to Into the Terminal, episode 45. Hard to believe that we just started this at like 8 months ago and we're already up to episode 45. But I am Eric, the IT guy Hendricks, and today we're talking about managing Podman containers as pods. And joining me, as always, is the undeniable Scott McBrien.
Hello. So, Eric, when we start talking about pods, I think that very early on in container world, we realized that having several applications that work together is really common. and that's where the idea of pods came from. So I know that we're about to do this, but in your example that we're going to dive into, what are the groups of applications that you're going to be running?
Yeah, great question. So we'll be doing an example where we put a workflow into place, and we're actually going to use WordPress as an example. And WordPress is an amazing tool to use in a containerized state. So the first one is the actual WordPress app. So it's what generates the web pages. It allows you to manage your blog posts, your website, loads in the images, but WordPress is run with a database on the back end. So right there, we've got two containers. We've got the database container, we've got the application container, and as we'll talk about here in just a minute, being able to put those in a box together really helps, because that you can use the same permission sets, you could use the same service account, you can use the containers within a pod can actually communicate with each other across any port necessary without any additional configuration. And if we wanted to get really crazy, we could include something like Nginx. You can get more advanced with your configuration based on your needs. But for today, we're going to do two pods, just an app container and a database container.
Yeah, and before we transitioned, Eric showed you the infrastructure pod or infrastructure container that was created as part of creating a pod. And that infrastructure container is what manages that networking stuff. And one of the nice things about pods is while we're grouping the applications together into a single unit of structure, we're still controlling access to it through this infrastructure container that's present in the pod. So we could do things like when we set up our port mapping to allow exterior traffic to come into our container, we can direct it to a specific member of the pod. So we can send it to all that traffic to our, say, WordPress application that can respond with the WordPress site data. But while our database is also running the same pod and can talk to the WordPress container, people from the outside can't directly contact it because it's only accessible within that private network that exists within the pod. And so using pods allows you to create this more advanced networking interconnect between your applications, but still deploy them as a single unit of, of data. One other thing that I would like to point out is that just like before, our pods run as containers and they're like held within the same Linux context. Then you can run them as rootless containers, meaning that regular people can run them, but that means that they're regular people privileged on the system, as opposed to being able to become elevated as root activities. So like all the same security things and best practice things that we've talked about previously, those also apply to pods. And in Red Hat Enterprise Linux 9, Eric, what Podman change did we get? Got a new version.
Yeah, got a new version. We're up to 4 dot something, actually. Here, let's find out.
And some of the changes that came into Podman 4 was the ability to do multiple IP addresses to a container, IPv6 support. So they did a lot of networking changes to help leverage even more complex interconnection and networking and deployment of containerized workloads.
I feel like this is the point in the episode where I go, right you are, Scott. So why don't we go in and start actually building our container here. So as you can see, we're running Podman 4.1.1. And if I can type. All right, so hold on to your hats because this command is going to be kind of scary looking. But let's, like we did before, let's walk through this piece by piece. So we're calling the Podman utility. We want this to run in daemon mode. We want the container to restart always, which means that if it should crash, it would be restored. And And then let's do, one of the things I wanted to point out was that we can actually create a pod from the podman run command. So you just do tac pod and then specify that this is going to be a new pod. And because we're super creative, let's just call it into the terminal 2, ITT02. And we're going to specify our super secret root password for the SQL database. We'll give the database a name, create a database user, and give that user a super secret password. And so notice here that we're also specifying a port. So we want to use a non-privileged port. Now, granted, do as we say, not as I'm doing here, because we're creating this as root. But we could actually create ourselves a like a website user, some kind of a service account, and open the port up on a non-standard port, and then redirect it internally to port 80. So as far as the container itself is concerned, it's talking over port 80. And as Iron Sysadmin pointed out in the chat, the web app and the database can talk to each other over their port without that port being exposed to the outside world. So we're going to actually expose this app on port 8080 and redirect that inside the pod to port 80. And then we're going to we'll name the container WordPress DB, and then we want to pull down MariaDB, and this will pull down the latest container, or the latest container image. So I know that MariaDB hosts their stuff out on docker.io, so we'll go ahead and start pulling it from there. While that's pulling, special thanks to Mohit Goyal. I think it's Goyal. Sorry if I butchered your last name, but Mohit wrote an amazing blog that we'll have in the show notes. In fact, I have a WordPress website for the IT guy, and I use this very same setup. So awesome blog post. We'll get that linked in the episode, or in the show notes. So that is our database container. Let's go ahead and pull up our web container. So much the same, we want a podman run it in the background, restart always, add it to ITT02, and then we'll give it the necessary variables like the database name, database user, the password, and we're going to have it connect over localhost since it's all self-contained. And now we'll call it WP Web and pull down the WordPress image. So kind of a garbled up mess of a command, but when you step through it and kind of build this command as you go, it's much easier to validate. So it pulled down all the layers needed for its for the WordPress for the WordPress pod that we just set up. So let's go ahead and check and make sure. So ITT still running with the 2 containers from the top of the show, but ITT02 ITT02 we now see that we have 3 containers. So if we do a PS on those containers, what did I mistype here? That's what I get for not copying and pasting. There we go.
Live by the copy paste.
I know here, and for the sake of visibility, let's go ahead and redo that. So notice that we've got a couple of infrastructure pods here. We've got the one from ITT earlier, and then the one we just spun up a couple of minutes ago. And then we've got Gallant Spence, which was from the top of the show. But then here at the bottom, we actually have WPDB and WP Web. So we've got both of those running. We've got the port exposed, the pod's up. So why don't we see if this worked? Hold on, I heard Scott's voice echo in my brain. So we're going to pull in, we're going to do a curl on localhost port 8080 because we're not exposing it over 80, and then the install page for WordPress. So notice that notice that we've got some troubleshooting information here, and we can see that it's pulling from WP config. So believe it or not, this actually worked, and we have a WordPress site that is ready for us to. We have a WordPress site that is ready to be configured and deployed out onto the interwebs.
Excellent.
I know, I'm just as shocked as you all are that worked.
Copy paste. Who knew? Who knew?
So as Scott hinted at the beginning of the show, there's a difference between running containers and having things like Podman auto updates, which was part of Podman 4.0. You can actually have a timer that automatically checks to make sure that there's not a new version of your container image. It could pull it down, restart, and redeploy the container. But what you can do, or there's a difference between that type of automation and orchestration. So we've all heard by now that Kubernetes is like the next thing that's going to eat the world. And as Shantanu hinted at, Red Hat actually has a container orchestrator as well, and that's OpenShift, which is built on top of Kubernetes and a lot of the other modules and components that make up a lot of the container platform. So the way I like to describe it is, in the orchestration world, you have the choose your own adventure. So that's the I'm going to go buy a box of miscellaneous Lego pieces and build my own Kubernetes. Or there's the Red Hat OpenShift approach, where you go out and you actually buy your Lego Millennium Falcon and you follow the step-by-step instructions to build your thing. So there are orchestration options. What we've demonstrated is the automation piece. So Scott, why don't you talk a little bit about how we go from just running a few pods on a server with a few containers each to having a need for something a little bit more robust?
Yeah, so I think we kind of see the direction of that with the pod that we just set up, right? At this point, we can spin up as many WordPresses as we want. We can copy it to other local registries. We can share it to other organizations within our company, and they can deploy it, right? So we have this repeatability in our pod where we can take all the configuration that we've done and share it and deploy it. But then there's the other piece of it, which is like, how do we actually manage the deployment? And there are additional pieces that come with RHEL, like Eric mentioned, automatic updates that you can configure with systemd. We can do things like shell scripts to manage the Podman commands and other stuff. Right? We could write systemd units to do it so that when the system boots, it automatically deploys it. But where we start to get into trouble is when our really simple container that we set up becomes a little more complex. Like what happens when instead of a locally running database that just stores things ephemerally inside the container, we now need to store that permanently because we need to be able to reproduce the state over time. So now we're going to like tie disk resources to our containers. And now we're talking about doing that across multiple hosts and multiple departments. So like now we're talking about SAN management and like a bunch of other stuff that makes our application far more complex. Well, could one address that with shell scripts and Ansible and other tools? Sure. But at some point, like you're building a lot of custom glue code to make all those things work. Oh, and then by the way, you need to do things like monitor the deployment and have some resiliency in case something dies and can be spun up somewhere else, right? And that's where orchestration really shines, because inside the orchestrator, we have all that framework and process and management and reporting and stuff that goes along with that level of scale and complexity that just deploying a pod doesn't require. So I think that like that's one of the big things that sure you can automate and you can do some really complex automations, but you also need to think about like how much effort am I putting into the automations and maintaining them over time and enhancing them as my application becomes more complex. versus should I move to a platform that includes a lot of that complexity that I will have to engineer for. All right. So automation versus orchestration. There's not like, oh, once I am at 7 containers in my pod, I need to move to an orchestrator. There's nothing like that, right? So it's more of a judgment where you have to think about what you're doing and whether that's really what you want to be doing in the future. So to help you get onto the like orchestrator path, once you've decided that you need to be there, we have a Podman command called Podman generate kube. And Eric, do you want to show an example of using Podman generate kube?
I will definitely do that, but to be honest, I wouldn't just consider Podman generate kube to be a transition command between running containers and pods on a RHEL host to moving to Kubernetes or OpenShift. To be perfectly honest, I use Podman generate kube in my home lab to manage the 3 or 4 pods that are running different applications that I host here at home. I've got like a Minecraft server, a Plex server, and a WordPress server. So for my setup, I don't need something as robust as OpenShift to reschedule my containers. Though, whenever our Plex server goes down and I get the trouble ticket from my wife that says, "Hey, I can't watch my show." Sometimes I think maybe some container orchestration might be in order. But to be perfectly honest, the Podman generate kube makes it really easy to ensure that your pod configuration is always able to be redeployed, or that you can migrate it from one RHEL host to another. But obviously, yeah, the end goal of Podman generate kube is so that you can really do development work on your local machine. So if you're running some sort of Linux machine that supports Podman, like a RHEL workstation or something along those lines, you can actually do all of your container development work locally and then push that image to a repository, to a container repo, and then deploy it to other systems. So the command we want to use, as Scott pointed out, and that is not what I just copy pasted, or that's not what I thought I copied. Let me see here. So the command that Scott was alluding to is Podman generate kube, and so we're actually going to pull the configuration from ITTO2. So that is the WordPress pod that we built. And we are going to write that to a YAML file, and we'll be super descriptive and call it ITTO2. And that's it. It takes all the container configuration, it takes all the pod configuration, and it shows and it populates this configuration file. And so it's got all of this Kubernetes focused YAML. So you notice that here's our database configuration, there's our WordPress configuration. It's all stored in this one file. And now what we can do is do a and now I'm going off script here, and my keyboard just let's see. I'm at Podman. I think it's Podman play. And this will probably error because one, I didn't get it right, but also because ITTO2 already exists. That's what I get for going off script. Let's see here, Podman. There, that should help Shantanu feel better. He was very sad that our WordPress worked without any issues. Oh, there we go. So I was right. It's Podman play. But I forgot to specify that that's a Kubernetes configuration. So yeah, it already exists, but we can either redeploy the existing pod, we can copy this file over to another system, and it'll pull down all the same containers, give them the same names, the same credentials, or because we've been really successful, and now the Into the Terminal consulting agency has like 50 different WordPress sites that we don't want to manage by hand, we can then import those into OpenShift or Kubernetes. So thank you to Nate.
in the chat, I linked a Level Up Hour episode, which that was a live stream show I used to work on, where we actually did a generic kube from Podman and then imported that into the OpenShift cluster and deployed the same application over there. So if somebody's interested in making that migration or that adjustment, there's a practical application example of doing it.
And so, little out of scope for this show, but I did want to surface a comment that we had as soon as my chat window updates, so I can actually put it on the screen. Time for a reboot, I can tell. So Aaron was looking for a free or cheaper solution for OpenShift that kind of falls in line with a Red Hat Enterprise Linux developer subscription. And I think it's changed names now. I don't think it's called Microshift anymore, but Microshift is a single node OpenShift cluster. You can run it on your laptop. I've spun it up in a virtual machine in my home lab before. But Microshift is a great option. It might be OpenShift Developer or something like that now. But yeah, look for Microshift, and that'll point you in the right direction. So we're approaching the bottom of the hour. So if you have any other questions about Podman pods or orchestration versus container management, now would be the time. But all of these links will be in the show notes within the next couple of hours. We'll go and put in chapter markers, links to the Level Up Hour, the Into the Terminal episode on containers that we ran, and then from there. So Aaron found some bicycle related stuff. So we'll find the link to that and we'll put it in the show notes. Sorry about that.
Well, while we're talking about bicycles, Shantanu is litigating Kubernetes and its position in the orchestration role for containers. So yeah, like there are others, but OpenShift is ours, and we love it, and we'll continue to love it.
Oh, there you go. Aaron will follow up with you. All right. So we have another episode arc that we wanted to announce. We just did a short arc on different workloads like databases and web apps, and now we showed you how to containerize those today. So hey, bonus episode, I guess. But coming up, starting next week, we have a new episode arc coming up talking about troubleshooting. So we're going to find interesting ways to break systems, whether that's disk performance or permissions errors or something along those lines. And then I'm going to try and make Scott fix them live on air.
What could possibly go wrong?
Yeah, what could possibly go wrong? But so yeah, definitely join us a week from now, and then in 2 weeks we'll have another troubleshooting episode. But we'll also be live with RHEL Presents, talking about Ansible automation platform and how AAP and RHEL can work together. So that'll be RHEL Presents here in 2 weeks. But other than that, please leave your comments and questions on the YouTube video here below. Make sure to like and subscribe. That's how more people find our content and bring in new folks to our community and more great questions. And but other than that, on behalf of Scott McBrien, on the entire Red Hat Enterprise Linux team, and myself, Eric the IT Guy, I thank you all for joining us, and we will see you again in a week. Take care.